You use agent orchestration all the time, but have you ever wondered what's actually happening under the hood? In the next few minutes, we're breaking agent orchestration down into ideas anyone can picture. No jargon, no assumptions. Let's get into it. Okay, let me ask you something. You've been to Chennai Airport, right? Or at least you've seen it on TV. Imagine there are 20 planes in the air at the same time, all wanting to land or take off. Now, do those pilots just decide on their own? Okay, I'll land now. You go up, no problem. No, that would be a disaster. There's one person in a tower, the air traffic controller, who knows where every single plane is, what needs to happen next, and in what order everything should move. The pilots are skilled. The planes are powerful. But without that controller, nothing works safely. Now bring that same idea into AI systems. When you're building something complex, say a system that reads a customer complaint, checks order history, generates a reply, and flags it for a human if needed, you don't have one AI doing all of that. You have multiple AI agents, each specialized for one job. One reads and understands text. One queries the database, one writes the reply, one decides if a human should step in. But here's the thing, who tells them what to do and when? That's where agent orchestration comes in. The orchestrator is your air traffic controller. It receives the big task, breaks it down, decides which agent handles what, in what order, and makes sure the outputs from one agent feed correctly into the next. The whole system behaves like one intelligent unit, even though multiple agents are running under the hood. Why does this matter for you? Because real-world AI products are not single-agent systems. They are pipelines of agents working together. And the orchestration layer is what makes that pipeline actually work. Okay, let me take you to a hospital emergency room for a second. Imagine an accident victim comes in. The paramedic in the ambulance stabilizes them, stops the bleeding, keeps them breathing. Job done. Now the paramedic hands that patient to the triage nurse. The nurse checks vitals, records everything, decides the severity. Job done. Nurse hands to the doctor. Doctor examines, orders tests, makes a diagnosis. Job done. Doctor hands to the surgeon. Surgeon operates. Each person waits for the previous one to finish. Nobody jumps the queue. Nobody skips a step. That is exactly how handoff and sequential orchestration works in AI agents. You have a chain of agents. Agent 1 does its job completely, then passes its output to Agent 2. Agent 2 takes that output as its input, does its job, passes to Agent 3. One at a time. Fixed order. No parallelism, no shortcuts. So in a real system, imagine you are building a content pipeline. Agent 1 reads a research topic and pulls key facts. It finishes, hands that summary to Agent 2. Agent 2 takes those facts and drafts an article. It finishes, hands the draft to Agent 3. Agent 3 edits and formats it for publishing. Clean, predictable. Each agent only sees what the previous one gave it. Now, why does this matter to you? Because most real workflows have dependencies. You cannot edit something that has not been written yet. You cannot diagnose before you examine. Sequential flow respects those dependencies. It keeps things reliable, debuggable, and easy to understand, which is exactly what you want when you are building your first agentic system. Okay, let me paint a picture for you. Imagine it is 2 days before a big product launch. The CEO calls a war room meeting and says, "Everyone, go work on your piece." The marketing team goes off and creates the campaign. The legal team reviews all the compliance documents. The supply chain team confirms inventory is ready. Nobody is sitting around waiting for the other team to finish. All three teams are running their work at the same time, completely independently. Then on launch day, the CEO sits down and collects all three reports together and says, "Great, we are ready to go." That is exactly how concurrent orchestration works with AI agents. Instead of one agent finishing its task and then passing it to the next one, you have multiple agents running their tasks at the same time, in parallel, independently. One agent might be summarizing customer reviews, another is pulling competitor pricing, another is checking stock levels, all happening simultaneously. Then once they all finish, a central orchestrator collects all those results together and combines them into one final output. Now, why does this matter to you as someone building real-world AI systems? Because speed is everything. If you ran those three agents one after another, you are stacking the wait times. But when you run them concurrently, the total time is roughly as long as the slowest single agent, not all three added together. That is a massive difference when your system is handling real users in production. So concurrent orchestration is not just a fancy pattern, it is how you build agents that are actually fast enough to be useful. Okay, imagine you're in a hospital ICU. There's one patient, and around that bed, you have a cardiologist, a pulmonologist, a neurologist, and a senior nurse, all of them working together, all focused on that one person at the same time. Nobody leaves, nobody waits for someone else to finish. That is group orchestration. In AI agent systems, group orchestration means you take a fixed set of specialized agents, you bring them together, and they all collaborate on one shared goal simultaneously. Each agent contributes from its own area, and together they produce something none of them could handle alone. Now, flip the scene. You're at Changi Airport in Singapore. You walk up to the customer support desk. You start describing your problem. Maybe your bag is missing. Maybe you need help in Tamil. And before you even finish your sentence, the system has already figured out exactly which specialist to send you to. Luggage issue, routing you to the baggage team. Language barrier, pulling in a Tamil-speaking agent automatically. That is magnetic orchestration. It does not use a fixed team. Instead, it listens to the context of what you're asking right now, and it dynamically pulls in whichever specialized agent is the most relevant match for that exact moment. So, why does this distinction matter for you as someone building AI systems? Group orchestration gives you coordination and depth, great for complex problems where many minds need to work in parallel. Magnetic orchestration gives you flexibility and precision, great for unpredictable requests where the right expert changes every single time. Knowing when to use which one, that is what separates a good system design from a great one. Okay, let me ask you something. You've ordered something on Flipkart, right? Think about what actually happens after you click that buy button. First, your payment gets verified. That has to happen before anything else. That's sequential. Then, at the same time, the warehouse team starts picking your item, and the fraud check team is scanning your transaction. Both happening together. That's concurrent. Now, based on your PIN code, the system pulls in the right delivery partner. Maybe eCart for your area, maybe someone else. The system is attracting the right agent like a magnet. And if something goes wrong and you raise a return request, a whole group of agents, customer support, logistics, refund processor, all coordinate together to close that ticket. That's group orchestration. One order, 4 different orchestration styles, all working as one smooth system. That's exactly what hybrid orchestration is. In real work, no single pattern is enough. A payment pipeline needs sequence. Background checks need concurrency. Routing needs magnetic pull. Exception handling needs group coordination. Real-world workflows are messy and complex, and trying to force them into one pattern will always break somewhere. Hybrid orchestration lets you mix and match, use the right pattern for the right step inside the same overall workflow. This is what senior engineers actually design when they build production systems. Not just one pattern they read about, but a combination that fits the problem. So when you're thinking about your agents, ask yourself, which part needs to be strict and ordered? Which parts can run together? Where do I need smart routing? Where do I need a team? Answer those questions and you're already thinking in hybrid. And that's it. You now understand the core ideas, not just the buzzwords. If this clicked for you, follow Hired by Basics for more explainers like this one. See you in the next video.